Hi friends, welcome back in the series of recommendation system. So today we will have a project on recommendation system. So basically this project will be based on mobile phone recommendation to a user, right? So let's start. So yeah, the domain is smartphone and electronics. So the context is this. So India is the second largest market globally for smartphones after China. About 134 million smartphones were sold across India in the year 2017, and is estimated in increased to about 442 million in 2022, right? So this was a data set, and based on that data set we provided some information like the buying of product and the customer behavior on the product, right? So on so forth. So this is the data description, like what all the attribute that we have. Now the main objective is we will build a recommendation system. Of course we'll be using popularity based and collaborating filtering method to recommend mobile phones to a user which are most popular and personalized respectively. Now first we are installing the surprise library. So pip install surprise, then that is basically setting up the environment. This step can vary for different user. So we have used Linux command to set path on our desired folder, right? So this is our completely step. So here you can see that this is in the Google Colab, and now we are navigating to that directory. So the very first step is to import the necessary library and read the provided CSVs as a data frame and perform the blue steps. So we import the necessary library like core package, visualization package, matplot, seaborn, plotly, libraries for recommendation system like default dictionary, SVD, KNN with mean, data set accuracy, reader, and of course the model selection for cross validation and trend test split. Now we are reading the data set. So these are the 6 data set that we have. I'll be providing the link for all these in the description, so you can get it from there. And review one dot head. So this is the review one, that is our user review file one data set, and similarly for 2, 3, 4 and up to 6th, right? So these will contain the head and the respective URLs. So now check whether the column name are same in all data frames. So this step is basically optional. So this is just because to check for our information. So all of np.unique review one dot columns to list equals to np.unique review one dot column dot to list plus review 2, 3, 4 up to 6, and so on so forth. We got that. Okay, we have the same columns, right? Now merge all the provided CSV into one data frame. So merge the data set into a single data frame. So reviews equals to pd.concat review 1, review 2, review 3 up to review 6, and ignore index equals to true. Now print the number of rows in the reviews data frame, review.shape 0, and the number of column in the final data frame. So here you can see that the rows in the review data frame and the column in the final data frame. Now print top 5 rows of the reviews data frame. So how we'll get that? Of course we can directly use the review.head. Last 5 rows of the review data frame, of course we'll use the reviews.tail. So this way you got the top 5 rows of the review data frame, and similarly top 5 last 5 rows of the reviews data frame, right? Now deleting the individually review data frame. So we are deleting all these review 1, 2, 3, 4, 5, 6. Now explore, understand the data and share at least 2 observations. So here we have the insight is review info. So here we get some information from here. Now we are checking information like their non-null counts and their data types. Now checking for missing values in the data set. So reviews dot is null dot sum. So here you can see that these are the null values that we have in these 4-5 attributes. So except score and score max, which are of float type, all other features are of object type. So here we got it from here. Now feature data should be of data type, and feature date should be of date type. Also score, score max, extract and author column have null values. So we'll do the null value imputation. So df equals to reviews dot is na dot sum dot round 2, so up to 2. df1 equals to df multiplied by 100 divided by reviews dot shape of 0, and again rounding it to up to 2. Now print missing count and percentage for each column, right? So df dot as type string plus df1 dot as type string. So here you can see that we will get in a percentage, like how what missing count and percentage for each columns. So like for score, this is the count and this is the percentage. Now deleting df and df1, so three features have approximately 4.5% of missing data: score, score max and author. And score max have the same number of missing values. So number of unique values in data set reviews dot n unique. So here you can see that the unique values for phone URL, date, language, country, so on so forth. So looking at the phone URL, that is this one. The phone name is written in a single string separated by / delimiter character. So now we manipulating the phone URL to identify the relevant column. So review of phone equals to reviews of phone URL dot string dot split on the basis of forward / dot applying lambda on column for second column, and replacing all the hyphen with space, right? And regex, of course, that is true. Now review product equals to review phone, so review phone dot unique. So array, you can see that Samsung Galaxy S8, so Samsung Galaxy S6 8 plus, Samsung Galaxy S8 plus. So we got the value now precisely. Now review product dot shape, so this is still our shape here. Checking the score column, so review dot score dot unique. So here you can see that the score that we have in decimal. Now duplicate a value in the data set, so checking if there are any duplicated and getting the sum. So yes, we have a lot of duplicate values. Now copying the reviews file to pre-process the data and keeping the original data set intact. So review 1 equals to reviews dot copy, so review 1 dot head. So here what we can do is, so here you can see the head of this. Now review 1 dot shape, so this is the shape. Round off score to the nearest integer, so rounding off the values in score column. So review 1 dot review 1 of score equals to review 1 score dot round 0 as type integer 64. Unique value in score, so print unique in score feature list of review 1 dot score dot unique. So uniques in score feature, so 10 6 9 4 8, so all these we have. Check for missing values, impute the missing values of any. So removing the missing value, so review 1 dot drop na in place equals to true. Removing values in author column which resemble unknown, so unknown equals to anonymous, Inyar Kundin, right? And so on so forth, all these values on the basis of author. And imputing values in score feature, so review 1 dot review 1 of score, review 1 of score dot fill na if there are any with the median values. Now check for duplicate value and remove them if any. So dropping duplicates, so simply we use review 1 dot drop duplicate, so this will delete all the duplicates. Now printing overall percentage samples are dropped. So here if we print it, so overall 11.63% samples are dropped now, right? Now if we again get the head, so review 1 dot head, so this is our head. Keep only 1 million data sample, use random state 612. So keeping only 1 million of the data set, so review 1m equals to review 1 dot sample n equals to 1 million, random state equals to 612. So this is any integer number. Now number of rows in the 1 million data set, so here you can see that this is the data, and number of columns present in the 1 million data set, so we have 12. Now drop irrelevant features, keep feature like author, product and score. So determining the relevant feature, so relevant feature equals to author, product and score. Removing the irrelevant feature, so review 1 equals to review 1 dot log of relevant feature. Now number of rows in the data set after removing the irrelevant feature, so 12505 5, number of column present in the new data set equals to 3. Now answer the following questions, right? So basically there were some questions, so we are trying to make them in a step so you can easily understand it, you can easily correlate this with your problem, which will help you in your problem statements. Now identify most rated products. So here what are the main thing is starting. So identifying the most rated feature product. So what we'll do, we will do value counts dot head. So here you can see that head we are getting, and Samsung Galaxy S5, so it has 11,749. Now as we can see from above all, the most rated product is Samsung Galaxy S45, right? And this is the rating for it. Now visualization for seeing which score has occurred most. So sns.count plot data equals to review of 1 million, x equals to score, so plt.show. So here you can see that this is the visualization of the count plot, and here we have the score and here we have the count. So if the score is 10, so count you can see that it is nearly to 5 lakh. Now identify the user with most number of reviews. So top 10 author with the score of 10. So review of score equals to 10. Then author dot value counts dot head 10. So we need top 10 values. So here you can see that Amazon customer, client Amazon Condi, so clients D Amazon. So all these the author. Users with highest number of reviews. So here user with highest number of reviews, so we normally get the author and do the value count. So here you can see that Amazon customer has the highest amongst all. Now select the data with product having more than 50 ratings and user who have given more than 50 ratings. Report the shape of the final data set. So select the data with product having more than 50 ratings and user who have given more than 50 ratings. So author 50 equals to review 1 author dot value count author 50 auth 50 is greater than 50 than index dot to list. Similarly we do for product 50, right? Now at last when we print the review of 50 on rows and review, and then if we check the if we check the shape of this review and the review, and first we get the author 50, then product 50, and then we make it as review 50, right? So this will become our review. So if we check the review of rows and columns, so here we have, and this is the head. So this is author, product and score. So this way we are getting the values. Now 500 uniques in author from review 50. So of course we will do a review 50 author of unique, and we need 500 values. So here you can see that James, Paul, Robert, Michael, so on so forth. These are all the 500 reviews. Now 500 unique in product from review 50. So of course to get for product we simply call the attribute name, and rest thing is same for 500. Now modeling. So here we build a popularity based model and recommend top 5 mobile phone. So build a popularity based model and recommend top 5 mobile phones. So here defining pop recommendation, and we are passing the data frame here. Now rating mean, we are getting it right from the group buying the product and score, then doing the mean. Similarly rating mean count, right, counting it, rating mean count. So here rating mean count dot sorting the values based on score and rating counts. Ascending is false, so here display, so it will definitely display all the rating means. So if we call this function passing a review 50, so here the top 5 recommendation are follows. So here you can see that these are the top 5 recommendation. Now pop recommendation of review 1. So the top 5 recommendation are as follows. So here you can see that these are the top 5 recommendation. Now build a collaborative filtering model using SVD. You can use SVD from Surprise or build it from scratch. In case you are building it from scratch, you can limit your data point to 5000 sample if you face memory issues, right? Build a collaborative filtering model using KNN with mean from surprise, and you can try both user based and of course the item based model. So rearranging the data frame for SBD, so data set dot load from DF, so review 50, author, product and score, reader equals to rating scale of 1 to 10. Similarly, we do the train test split, so here we are having test size of 25%, rest 75 will be for training the model. Now printing top 3 values from train set, so here for key values in k, then for v for k, then v for k, v in train dot ur dot items. So if k is less than equals to 2, right, so it will print the key of values, then print the top 3 values from the test set. So asterisk test 0 to 3. So here it is returning the top 3 from here. You can see the top 3 values from test set. So Philips, Tris, and this is what, Giovanni. This is Giovanni, right, and the mobile set name. Now defining SVD function train test, so SVD of random state 612, SVD dot fit of train, SVD prediction, SVD dot test of test. Now returning SVD prediction on SVD, so SVD prediction, SVD equals to SVD function train test, printing first few prediction values. Now RMSE values test set, so round accuracy dot RMSE, SVD prediction and SVD prediction up to 2 digit. Now first few prediction values, so here you can see that the first few prediction, if we get the RMSE, so 3.0680 RMSE values, so test set. So basically these are the clustering evaluation matrix. So RMSE values test set of 3.07. Now build a collaborating filtering model using KNN with mean from surprise. So you can try both user based and item based model, going with item based first. So here you can see KNN item train test, so KNN I equals to KNN with the means, k equals to 50, sim option name Pearson baseline, and user based is false. So KNN I dot fit of train, so KNN I prediction, KNN I dot test of test, right? Now returning KNN I prediction. So if we call this, so KNN I prediction, KNN I equals to KNN item training, calling the function on training and test data set. So first estimating biases using ALS. So bias is nothing but error occurred in the model, right? So computing the Pearson baseline similarity matrix, then done computing similarity matrix, right? So here again bias occurs due to oversimplification, so we can keep tracking on that. Now printing some prediction, then KNN I prediction 0 to 3. So some prediction, again we got some prediction like Philips, Motorola, Moto X2, right? RUI values, EST values details. Similarly prediction of this Triris, and similarly prediction for this Giovanni, right? Now RMSE of the model, so that is root mean squared error, so 2.9525, right? So we can say that 2.95 to the 2 decimal place. Build a collaborative filtering model using KNN means from surprise. You can try both user based and item based model. So now going again user based, so here KNN user train with this. So again we are doing the same thing here, and some prediction if we get this, so here it will print this. Now evaluate the collaborative filtering. Now evaluate the collaborative model. So print RMSE value. So SVD RMSE equals to round accuracy dot RMSE SVD prediction. Now similarly KNN I RMSE, KNN U RMSE. So this was for I prediction, this is for U prediction. So here you can see that RMSE value. So we can see that lowest RMSE error we got for KNN with mean item based model, and it is the best model so far. Now finally predicting the score. So for test user. So SVD prediction df equals to pd dot data frame SVD prediction, column equals to UID, IID, RUI, EST and details. Now printing the average prediction of test user is from here. The average rating by test user is, so here you can see that SVD prediction df of RUI of mean, and similarly the average error of by test user is, so SVD prediction df RUI minus SVD prediction df EST of mean, right? Now KNN I prediction df equals to PD dot data frame KNN I prediction, column we have again UID, IID, RUI, EST and details. So similarly the average prediction of test user, the average rating of the test user, and the average error by the test user. Now KNN U prediction df equals to PD dot data frame KNN U prediction and column, so UID, IID, RUI, EST and detail. So print the average prediction of test user is KNN U prediction df equals to EST dot mean. Now similarly print the average rating by test user is KNN U prediction df RUI dot mean. Similarly print the average error by test user is, so KNN U prediction df RUI minus KNN U prediction df of EST dot mean. So the average prediction of test user, the average rating by the test user, and the average error by the test user is this one. Now report your finding and inferences. So most author have rated 10 or 8. Data is skewed for Amazon and customers. Most popular phone overall is very cool T742. KNN with mean for item based as well as user based is very similar in performance. Now try and recommend top 5 product for test users. So top recommendation, so again defining a function, top recommendation, right? So prediction and n equals to 5, top number default dictionary having a list, then for UID, IID, so basically iterating among all the columns, for again iterating for the all the columns in top num dot item, so user rating dot sorting the values, then containing the UID and returning the top number. So similarly if we do the top 5 recommendations, so top 5 equals to top recommendation n, so calling the function, passing the KNNI prediction and the number 5. Now print the top 5 recommendations are, so applying the for loop. So here you can see that again the flip, we have Apple iPhone 6, then we have Huawei scanned P6, Samsung Galaxy Core, Sony Xperia E4, LG Z Flex 2, then Sony Ericsson K530i, Nokia 7500 Prism, right? Samsung B7 350, so on and so forth. We have these all top 5 recommendations. Now try other technique, example cross validation to get better results. So if we apply the SVD or the cross validate, so here SVD and doing the review 50 data set and measure RMSE and MAE, CV equals to 5, return train measure false, and job are 1, pre-dispatch 2 into number of jobs, and verbose equals to false. So if we do SVD of CV, so fit time we have this. So here you can see that test MEA, test RMSE, test time, right? Now mean RMSE SVD CV equals to SVD CV of test RMSE. So the SVD CV score we got is the mean RMSE, so 3.07. Now KNN with mean item based, so similarly we are doing with item based. So here you can see that it will estimate it and then we'll get the result of item based on KNNI CV. Now KNN item based CV score, yes, it is again 2.96 and here we got the 3.07, right? So yeah, now KNN with KNN mean with user base, so we are doing the same thing for RMSE and MAE for the user based, right? KNN U. Now KNN U dot CV we got it and the mean RMSE 3.00. Now plotting the bar plot for these three CV, CV, ICV and UCV, item and user. So here you can see that after cross validation, KNN-I model is giving the best results. So here you can see that. Now in what business scenario you should use popularity based recommendation system? So of course there are some common question which may help you a lot. So of course popularity based recommendation system can be useful in multiple scenario, like when there is no data about the user and item, when it is required to show most popular item in different categories along with personalized result, right? In what business scenario you should use CF based recommendation system? So here collaborating filtering is the most common technique used when it comes to building intelligent recommender system that can learn to give better recommendations as more information about user is collected. Now most websites like Amazon, YouTube and Netflix use collaborative filtering as a part of their sophisticated recommendation system. You can use this technique to build recommender that gives suggestions to a user on the basis of the likes and dislike of similar users, right? Next question is, what other possible method can you think of which can further improve the recommendation for different user? So there are multiple types of recommender systems. Some of them are mentioned below, which can be implemented to improve the result, like hybrid recommender system where it is content plus collaborative method, utility based recommender system, knowledge based recommender system, demographic based recommender system, and so on so forth. So yeah friend, this was all about this video. Hope you like it. Please do like, share and subscribe, because we need more like, more subscribe to build this platform, and our team is continuously working on it, so we need your support on this. So keep supporting, keep watching, stay tuned. All the best till then. Have a good time. Take care.